Welcome, grade 10. In this recording, I'm going to focus on Euclidean geometry. So that means it's going to be congruency and focusing on quadrilaterals, etc. So for the first question, it says, use this diagram below to prove that the opposite sides of a parallelogram are equal. So let's see, they help us. They say we must prove that triangle ABD is congruent to triangle CDB. So with congruency, remember all the four possibilities that you must try and prove. So either we're going to focus on three sides that are equal, or we're going to try and prove the side included angle and the side is equal. Or we're going to try and show that two angles and the side is equal. And lastly, for congruency, is the option of working with a 90-degree side and hypotenuse. But we will eliminate immediately number 4 because we don't have a 90-degree angle. Do we have angles? Yes, we have, because they said these sides are parallel. So if it is parallel, and what else did they say? They said, prove that the opposite sides. So we must prove. We can't make use of the fact that the opposite sides are equal because we need to prove they are equal, right? So you can't say it's a parallelogram. So what can we work with? The only information, we have to focus on the information given. The only information given here is that the two opposite sides are parallel. So having parallel sides, I know I can work with alternate angles. So this angle attached to that side will be equal to this angle attached to this side. Furthermore, I can say this angle attached to that side will be equal to this angle attached to this side because the sides are parallel. So immediately I see we can work with two angles and this side will be the common side. So number 3 is the only one we can work with. Proving congruency, we start with what's given. So in triangle ABD and triangle CDB, I'm going to start with B2. So I'm just going to say angle B2 is equal to angle D1. In this case, why don't I refer to B2 as ABD? The reason why is because they named the angles. So if they don't name the angles, then you must say ABD. So these are alternate angles. Because AB, make sure you make use of the right sides that are parallel. So AB is parallel to DC. Secondly, I'm going to work with B1. Angle B1 is equal to angle D2, same reason, alternate angles. But be careful. Now you would work with BC, which is parallel to AD. My third reason is just going to be that BD is equal to BD because it's the common side. And therefore, triangle ABD is congruent to triangle CDB. Side, angle, angle, the South African Airways. Next one. You need to understand how to approach a question, because very often we read the question and we look at what's given and we just say, oh, I can't do it. I know how to do it. No. you have to really battle with geometry, not always battle, but sometimes. So let's see, what do we have? So you approach it by reading the question. So for here, it says KLMN is a parallelogram. So how I would start off with it is, if they tell me something is a parallelogram, we need to know the properties of a parallelogram off by heart. You need to know it. Opposite sides are parallel. Opposite sides are equal. Opposite angles are equal. So in this case, they say this is a parallelogram, right? So that's how you approach it. That's how you do it. You start off filling in all the properties of a parallelogram. So immediately we can see that we are going to work with angles, because they gave us no side at all. They just gave us angles. So in this case, they say calculate the value of x. So I can just say now that angle L will actually be equal to angle N, opposite angles of a parallelogram. You see, so if you didn't know the properties of a parallelogram and you didn't start off by filling in, showing that this angle will be equal to that angle, then possibly you would have been lost. So it just becomes so simple, you know, if you just know the properties. Go and redraw the square, the rectangle, the rhombus, and the parallelogram, and the kite, of course, and go and check in your textbooks if you know the properties. Make associations, make use of little symbols. Right. So to calculate the value of x, we can just say, therefore, 5x plus 18 will be equal to 7x minus 30. So I'm just going to take this over. So it will be 7x minus 5x. You could have taken it over to the left side. And it's 18 plus 30. So 48 degrees will be equal to 2x. So therefore, x will be equal to 24 degrees. So now we know if x is equal to 24, we can work out whatever they ask us to work out now. So let's first work out 5x plus 18, just for the fun of it. So 5x plus 18 is going to be equal to 5 times 24 plus 18 degrees. Let's work it out quickly. That's 5 times 24 plus 18, and that gives you 138 degrees. So that one is 138. Let's double check this one to see if it actually makes sense. So this will be 7 times 24 minus 30. Pop it into the calculator and you'll see it's also equal to 138 degrees. Now for this question, it says angle LKN. LKN is equal to 4y. So this one is a 4y. Determine the value of y. So what we can do here is we can work with co-interior angles, because 5x plus 18 plus this angle will be equal to 180 degrees. Why? Because of the lines that are parallel. So let's do that. So I'm going to say angle L plus angle K will be equal to 180. Co-interior angles, because LM is parallel to KN. And then 5x plus 18 plus 4y will be equal to 180. And we just know that x is equal to 24. I'm just going to show here. I will just write here, x is equal to 24, just to show the examiner where I got it from. So if we already worked this out there, so this we know is going to be 138 plus 4y equal to 180. So 4y will be equal to, oh yeah, okay, so you just say 180 minus 138. Okay, so it's 180 minus 138. Right? And that gives me 42 degrees. I must say, if I look at the memo, there's quite a few mistakes in this one. So this comes from the Eastern Cape, November 2020. Unfortunately, yeah, no, I see this one. Yeah, there's small mistakes here, but it's not, it's okay. All right, it's not too bad here and there. It's just the way that they write it, because they wrote it in the memo that, yeah, I suppose it's okay. No, I think I'm overcritical. Right, so here they say find the value of y. So y, I am overcritical, that it's right, it's not wrong. 42 divided by 4 is then 10,5. Apologies, there was no mistake here. Right, so that's the value of y. Next one. Sure. Quite a lot of drawings, aren't there? It says here in this diagram, A, B, C, D is a parallelogram. So I'm going to work, okay, I'll work in black here. A, B, C, D is a parallelogram. So if it's a parallelogram, I'm immediately going to fill in the properties. Parallel, 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 parallel. And I know that that angle and that angle will be equal. That one will be equal to that one. And this one is equal to that one. It further says, okay, it also says here, AD, right? So AD is equal to BE. Okay, so that's another information that if we don't scrutinize the question, you can't, solve it. Because if we don't indicate this, that AD is equal to BE, we will be stuck later on. Angle A is 124. So if that one is 124, I immediately know this one is 124. Then it says that ED bisects. It means it cuts it in half, BEF. BEF. Right, so that means this angle and this angle will be equal. And it just says that BEFD is a quadrilateral. It just means it's a shape with 4 lines. Calculate the reasons, the values of x and y. So one of my pupils, Connie, asked me, does it matter if we first work out y? I would say yes. They might be friendly and kind and give you all the marks, but if they say the values of x and y, always work in alphabetical order, right? So you just work in alphabetical order. So we must try and figure out x first. By looking at the information here, Yeah, I have that one is 124, that one is 124. Okay, what I'm going to do here. So you see, how do I approach this? And by the way that I approach this question can vary. Someone else can start at a total other angle. But I'm looking at the X. I'm focusing on the X. And I'm looking at the information that's been given. So looking at this, what I'm going to do, I'm going to say angle A is equal to this angle C, because opposite angles of a parallelogram. Then I'm going to work with adjacent angles on a straight line. So then this will give me 180 minus 124. So this one is going to give me 56. Then I'm going to say, but this angle and that angle is equal because it's angles opposite equal sides. And lastly, I'm then going to work with interior angles of a triangle. You see how I approach it? I look at the big picture. So before you just start writing down, sit back and use your pencil, because then you can erase it. So with your pencil, you see how much I can do with my symbols. So I always suggest you work with symbols and then try and see what can you do. Okay, so I'm going to start off saying that angle A is equal to angle C is equal to 124 degrees, because they said A is 124. But you must always give you a reason. So why can I say that? Because it's the opposite angles of a parallelogram. Opposite angles of a parallelogram are equal. That and that's equal. Then I'm just going to work here with adjacent angles on a straight line. So I'm going to say, you see, it's not been named here. So I'm going to say, you know what, let's first get that one. So I'm going to say angle DCB plus BCE. BCE is equal to 180 degrees. Adjacent angles on a straight line. But it could be that some of you wanted to start off by saying that, the sides are equal. AD is equal to BC and AD is equal to BE. Therefore, these two sides will be equal. Some of you could have started off with that. Doesn't matter. Right? So DCB is actually 124 degrees. So therefore, BCE will be 180 minus 124, which is 56 degrees. And with your new given information that you've figured out, you fill it in on the drawing. Applying logic here, we now need to prove that those two sides are equal. I'm going to say AD is equal to BC, opposite sides of a parallelogram. Right, so those two sides are equal, but they also said here that AD, so I'm going to say, but AD is equal to BE, given, they told us. And you see what I do? Well, not just me, it just helps. If you write the same numbers or the same, like AD, you write the other AD underneath. Don't go and write it on the other side, then it's sort of difficult to see. So if the two ADs are equal, therefore BC will be equal to BE. So therefore the BC will be equal to BE. And therefore angle BCE will be equal, you can just, no, I'm not going to say angle E. Let's be proper and say BEC. BEC, and that will be equal to 56 degrees. Angles opposite equal sides. Right, so now we have the X value. Now that we have the X value, which is, oh, we haven't, sorry, where am I? So now we still have to work out the X. Sorry, I nearly skipped a step here. Now we're going to do the interior angles of that triangle. So I'm going to say X plus 56 degrees plus 56 degrees will be equal to 180 interior angles of a triangle. So X will be equal to 180 degrees minus 56 degrees plus 56 degrees, and that will give you 68 degrees. So my X is 68 degrees. Got it. And now we must all figure out angle Y. Okay, so I've got this one is 56 degrees. So what we can do now is we can just say that angle BED, angle BED, this one, BED, is equal to angle DEF, to this one, DEF, that's equal to 56 degrees. Why am I saying that? Because they said ED bisects. They gave it to us. Bisects BEF. So then in triangle DEF and triangle DEF, Y plus 56 degrees plus 90 degrees will be equal to 180 degrees. So therefore, if you minus everything, you'll get Y is equal to 34 degrees. Sharp. Yeah, so although this was quite a tricky one, you don't just give up. As I said, you fill in all the possible information, and then from there, you try and solve it. Right. Let's look at the next one. Now we're going to do a little bit of similarity. So they give us all these lengths. They say in this diagram below, FT is equal to 5 centimeters, etc., etc. And they say prove the triangle EFT is similar to triangle DCT. Now, normally with similarity, you need two angles. You need two angles. But do we have any angles here? No, we don't. So what we are going to do now is we're actually going to work with the similar, or the sides that would be in proportion. We work with this as if it's similar, right? As if it's similar. So I'm just going to say here, in triangle EFT and triangle DCT, I'm going to look at the following. So I'm going to work with EF, and I'm going to put it on top of DC, and I'm going to work it out. And then I'm going to work out FT on top of CT and work it out. And lastly, I'm going to work with ET over DDT and work it out. And if they are all equal, then we can assume and say, okay, so therefore the sides would be similar. Let's see, EF is 9 and DC is 18. So if you simplify that, it's 1/2. FT is 5 and CT is 10. Simplified, so it's 1/2. ET is 7 and DT is 14. That gives me 1/2. So because all the sides are equal in proportion, we can say therefore EFT is actually similar to triangle DCT. Sides in proportion. Right. Now, we actually know that all the sides are in proportion. So what can we do now? Now that we know that triangle, well, let's first see what are they asking now. They're saying, if it is further given that angle DFC, they say that angle is equal to TDC. TDC, okay. So they're telling us that those two angles are equal. And we need to prove that triangle FEC, I hate it if it's like not numbered. We must prove that triangle, of that angle FEC, this one. So what I do if I need to prove something, well, I'm just going to name it E1. We need to prove. So if I need to prove something, I just work with dotted lines, saying to myself, that's what I need to prove. I need to prove this dotted square or rectangle is equal to TFC. TFC. This one is slightly tricky. So that's why I want you to understand what I'm doing here. Okay. So if I must try and prove, I'm just naming that a F1. So I must basically try to prove that E1 is equal to F1. That's what we must prove. And from this, they gave us that F1 is actually equal to angle D. So looking at this, we have nothing to go on. But we proved that triangle EFT is similar to triangle DCT. That's proven. We just proved it in the previous question. Now, if two triangles are similar, if this one is similar to that one, then what do we know? Then we know the angles, the corresponding, not corresponding like parallel, but the angles will be equal. So let me show you. So I just want to work with a red pen. So out of this, out of similarity, we can derive now that, let's see, where's EFT? EFT. So we can derive that this one, I'm just going to indicate it with a rectangle. EFT will be equal to DCT, to DCT, to that one. So this one is equal to that one. EFT, okay, EFT, this one will be equal to DCT, to DCT. Oh, you see what's going on here? So there we already have a little cross. So that means that little one will also be equal to this one. Okay, and the last one here, EFT, EFT will be equal to DCT, DCT. Okay, those two will be equal. Right. And we must now try and see how we can connect all the dots. I just want to go back to black here. Right, so we must see how we can connect all of this. So firstly, which ones are we going to work with? F, E, C, right? F, E, C, angle F, E, C. Sorry, this should be a straight line. It doesn't look very straight yet. Sorry about that. F, E, C. So this angle, this one, is equal to TDC. TDC. Right, this one is equal. Is that correct? Let me just double check. FEC. FEC. Let's just fix this one quickly. I'm going to just start or just double check again with this one. It says in triangle EFT. So let's just double check that I've got this right. EFT. So there's EFT. So that's the E. That's right. That's the red one. Is equal to DCT. So this is where I should have put it there. You can make use of any symbols. Let's just start over with that one. So it's normally not too tricky if we just work with the correct angles. So we just prove it's similar. So EFT, right? EFT. So I made E, my little rectangle, will be equal to DCT. I just didn't indicate it correctly. Yeah. So it's DCT. So this would be the DCT. Furthermore, EFT, it's my little cross there, will be equal to DCT. DCT. So that would also be a little cross. And then the last one is just these two vertically opposite angles. So we must now decide which of these angles we are going to work with. And we also have to incorporate this, that DFC, this one is equal to, so this F1 is actually equal to TDC. TDC. So this one and that one is actually equal. And there you can now see it. Right. So we have to prove that E1 is equal to F1. And there we actually have it. So from this, it's quite clear that we are going to just work with this one and this one. See how easy it gets if you just work with the pictures. So how are you going to do it? Well, you could have set the whole tutti. You could have set that angle E1, or we can't say E1, it hasn't been named here. So you could have started off saying that FET is equal to TDC. Why? So I'm starting off with this angle is equal to this one. Why? Because of similarity. Similar triangles. And you don't have to say that this T1 and T2 is equal and that one is equal to that one. It's not necessary, because we realize that we only have to work with these little rectangles to prove that the little rectangles are equal. So now I've just said that this one, FET, this one is equal to TDC because of similar triangles. And furthermore, I'm going to say, so this one is a triangle, a rectangle and a rectangle. And then I'm going to say, but DFC, DFC is equal to TDC. You see, it's given there, it's equal to TDC. See what I'm doing? I'm writing the same angles underneath the same one. So this one and this one is equal. Why? It was given. So therefore, this FET, angle FET, this one will be equal to DFC, to DFC, to that one, to DFC. You see, and that's what we had to prove. So how did we start? We started off working with the similar triangles that we proved, and we just indicated all the angles that will be equal because of, you know, the similar triangles or the similar sides, and you just work with symbols. This is a question based on the midpoint theorem. Complete the following statement. They said for triangle ABC, so they just made use of triangle ABC. If D is a point on AB, so D is a point on AB, and E is a point on AC, so E is a point there, such that AD is equal to DB, and DE is parallel to BC. Then they ask us here, then what? Then AE will be equal to EC. And the reason would be midpoint theorem. And it won't just be equal. What else would be equal? Let me just write here midpoint theorem. Then it's not just this one that will be equal to this one, but DE will also be equal to half of BC. So why did I add two triangles here? It's just to show you the different possibilities with midpoint theorem. If they give you these two sides are equal and these two sides are equal, then you can come to the conclusion that this one, ST, okay. So if those two sides are equal and those two sides are equal, then you can derive that this line will be parallel to this one, and this length will be half of that length. So if it's 5, that one will be 10. If this one was 3, this one will be 6. If they give you the following, if they, like in this one, you know, the statement, if they say this side and this side is equal, and this side and that one is parallel, and this one is half of that one, then what conclusion can you come to? You can then say, therefore, this side will be equal to that side. So that's your midpoint theorem. This is a very old question, very popular question. They say here that we must prove that SEUT is a parallelogram. And you know now that you will make use of midpoint theorem because the question here was based on midpoint theorems. So now you know you'll have to work with it. So let's quickly finish off. In triangle DEF, DEF. So let's first see what did they give us. They say DS is equal to SE. They also say that EU is equal to UF. So this one is equal to that one. And they say ST is parallel. So this one is parallel to EF. Sure. So if they say prove that SEUT is a parallelogram, firstly, we need to understand when will it be a parallelogram. To prove a parallelogram, you sit with various options. If I can prove two pairs of opposite sides are equal, then I know it will be a parallelogram. If I can prove that one pair of sides are equal and parallel, then I know it's a parallelogram. If I can prove opposite angles are equal, then I know it's a parallelogram. And lastly, if I can prove this is the midpoint, meaning those two diagonal pieces are equal and those two are equal, then I know it's a parallelogram. So to prove this is a parallelogram and taking into consideration midpoint theorem, I'm not going to work with my diagonals because to prove that this inside, there's no diagonal here, so I'm not going to work with that. Opposite angles are equal. We don't even have one angle here, except if you want to work with corresponding angles, not going to work with that. So possibly we're going to work with opposite sides are equal, or, I forgot the other one. If we can just prove that two pairs of opposite sides are parallel, then it will also be a parallelogram. And the first thing that we do have here is that this side and this side is parallel. So that information we have already. So if I can somehow prove that this one is parallel to that one, then I'll be sorted. But now I first want you to look at this triangle, D, S, E, F, G. I just want you to look at this, ignore that little line. So from this information, they gave us that side is equal to this one, and that side is parallel to that one. So from that, what can we derive? We can derive that dt will be equal to tf, right? So I'm just going to say in triangle DEF, DS is actually equal to SE, it's given. ST is parallel to EF, that's given. Now, because these requirements are met, therefore I can say DT, therefore DT will be equal to TF, and ST will be equal to half of EF because of midpoint theorem. So now we know that that side will be equal to that side, and this whole side is parallel to that one that we know, but we just derived that that one and that one will be equal. How's that going to help me? Okay, so now I want you to look at the following. I'll indicate it with a red pen. So I'm trying to aim to prove that this side is parallel to that one. So if you focus on this triangle here, you just focus on this. Can you see that we already have here that this side is equal to that side? Because they said so. They said that DS is, they said EU is equal to EF. I actually want to just draw it for you here. Okay, we're nearly finished. There's T, D. So we just proved that this one and this one is equal. And they told us this one and this one is equal. So now we can derive that that side will be parallel to this one and it will be half. So we're going to derive that this side is parallel to that one. And then we've got it. Right. So I'm going to say now in triangle FDE. There from FDE. So if you struggle to see it, then just redraw it like I just did. We can say that FT is equal to DT. Why? It's derived. Or you can say proven. You can't say it's not derived. It's derived from the midpoint theorem. Or I will actually just say proven because we just proved it. Yeah. You see, we proved it there. So just say proven. And I'm going to say that EU is actually equal to UF. It's given. So therefore, this TU will be parallel. So therefore, TU will be parallel to ED or DE, and TU will be equal to half of ED. But you don't need this, but just, write the midpoint theorem complete here. So if they gave you sides and they said you have to prove the sides are equal or this one is half the size of that one, then you would have made use of this half. And why can I say it? Because of midpoint theorem. So therefore, ST, so we just proved, ST is parallel to EU and SE is parallel to TU. So therefore, SEUT is a parallelogram. Parallelogram. And what's your reason? Two pairs of opposite sides. Oh, I can't write there. That's coming up there. SEUT is a parallelogram. Reason, two pairs of opposite sides are parallel. Okay, I'm going over my limit there of parallel. Oh, there, I've got it. Okay, hope you understood this. I know it's tricky, I know it's complicated, but basically, how do you approach it? You read the question, you fill in everything with little symbols, and you look at the big picture, and then you must just try and write down the proof in an orderly manner. Maybe in the exam, start off with the stuff that's for you easier, like data handling and trigonometry, so that you can pocket all your marks. And then you tackle your geometry. Please remember, all questions are not always difficult. So if you struggle more than 5 minutes, move on, keep a space open on your answer paper, and then you come back to that one. Okay, all of the best for your papers.